All right, here we go. If we are doing dot product today, okay, not incredibly difficult here. If I want to find the dot product of two vectors being multiplied together, this number is going to tell me an amount, okay? Doesn't necessarily tell us a magnitude, but it gives us a strength value that we can use with a lot of different things. So if we have a vector, okay, written in the ij form, to find the dot product of the two things, all we're going to do is take the two x values, multiply them together, and then take the two y values, multiply them together, and then we're going to add those values, and that will tell me a dot product. So for example, in example 1 here, I've got I minus 6j, so I went ahead and rewrote those vectors. We take the x and the x, we multiply them together. We take the y and the y, we multiply them together. We add those together, we get negative 10. We take v times v. What two numbers am I multiplying together? 1 and 1, so it's 1 times 1, plus negative 6 times negative 6, I get 1, plus 36. 37 is going to be my value. If we do w times v, show me with your fingers, what'd you get when you took w times v? Did it matter which one came first? No, it's the same thing. V times w, w times v, it's the same setup because you're multiplying. It doesn't matter which one comes first. It's still going to be negative 10. We do w times w, so it's 2 times 2 plus 2 times 2. I get 4 plus 4, I get 8. Everybody with me so far? Not too bad at all. Then we're going to find the magnitude of v. Okay, if I want to find the magnitude of v, v up here again is 1 and negative 6. What would I need to do with that in order to find the magnitude? Pythagorean theorem. 1 squared plus negative 6 squared. 1 squared is 1. Negative 6 squared is 36. 1 plus 36 is 37. But what do I need to do with that thing? Square root it. Do you see how these two things have some similarities to them? This one, this scalar value that I got up here, was when I took two v's and put them together. This was just one v, so it makes sense that this is square root of 37. And if I multiply them together, it'd get me two of them. There's definitely some connections between that and magnitude. Okay, they're not exactly the same, but they're pretty similar. So if this was square root of 37, what do you think the magnitude of w is going to get me? Square root of 8, okay, or 2 radical 2, because we're doing 2 squared plus 2 squared. Same concept, dot products, okay? When you do a dot product, you take two vectors and your answer is just going to be a real number. It's just going to take two weird things and give me a number in the end. We refer to this as a scalar product. When we talk about the word scalar, it means it doesn't have a direction. It's just a value, okay? That's what's happening here. And that scalar product in these problems can be very helpful to us as we do them. Okay, one of the ways that we can use this dot product is it can allow us to calculate the angle between two vectors. So I have two vectors written down here below. This little formula right here, which I'll give it to you on a test. That formula will find the angle between the two vectors. All right, so to find the angle between vector u, which I hate writing in this form, so 5, 2, and negative 1, negative 8. To find the angle between the two, we are going to do that. So the first thing we should do is find the dot product. And then we could find the magnitude of u. And then we would need to find the magnitude of v. Go ahead and try to find those three things. All right, so we set this thing up. We're finding u times v. What did you do here to find u times v? Allison, what'd you do?
I took 5 times negative 1.
Good, so she's taking these two numbers, multiplying them together.
And then plus 2 times negative
2 times negative 8. So she's got negative 5 plus negative 16. Her scalar product is going to be negative 21. Everybody go with me on the first one. Cool. Grace, how did you find the magnitude of u? Pythagorean theorem. She's got 5 squared plus 2 squared. 5 squared is 25 plus 4 would be 29. What would I need to do with that 29? Square root it. That is the magnitude of u. Okay. I do a bad job here, and in calculus, they get mad at you when you do this. Okay, so I want to show it to you. Notice how I put an equal sign here? Are these two things really equal? They are not equal. And so be careful with that because I am being a bad math teacher there. This was the work that I needed to do to get my answer, but they're not necessarily equal. If on the calculus AP exam you were to put equal signs in between it, it's going to be wrong because they're not equal. So instead, you draw an arrow and it's just a thought process instead. Super dumb, but I'm just pointing that out to you now. Then we're finding V. If I'm finding the magnitude of V, okay, if I want to figure that value out, I'm going to do Pythagorean theorem here. So -1 squared plus -8 squared. 1 plus 64 square root of 65. Everybody cool with where I got all those numbers? Once I've done that, then I'm plugging into this formula right here. Cosine of theta equals the dot product divided by the two magnitudes multiplied together. Again, that's this formula right here. That's what I just set up. We are going to use our calculator to get that value. So what would I want to do to get theta by itself? How would I get rid of this cosine? Inverse cosine. So I'm just going to do this all in one shot on my calculator because that's how I like to do it. So I'm going to go second cosine. Make sure you're in degrees. But I went second cosine, inverse cosine. Then I'm going to type in that fraction. And if I'm typing it in, I want to type it in all at once. So I'm going to hit alpha F1 and use the fraction button. You don't have to do it that way. It's just going to make things easier. Okay. Otherwise, you got to worry about parentheses and do it all correctly. On top, I'm typing in -21. On bottom, I'm going to type in root 29. Hit the over button so I'm not underneath there anymore. And then go root 65. We type it all in. We hit enter. That is my answer, 118.926. Theta equals 118.926. And that is an angle. That's degrees. It's kind of a weird problem, but I got an answer for it. Understand what we just did. Look at it. Okay. Think about if I were to graph this for you. If I were to graph 5, 2. So I'm going to have this point right here. I'm going to graph 5, 2. So 1, 2, 3, 4, 5, 1, 2. That is my U vector. If I graph V, it's left 1 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. That's V. If you had to estimate what you think the difference is between that vector and that vector, what would you say that angle would be? Yeah, that guy right there. There's a reason. There's something that we actually did there. We found the difference between their two directions. That's the angle between those two vectors. Kind of makes sense what we did. Try the next one. Try letter B. Here we go. We are doing dot product V times W. So I'm taking 1 times 1 and then taking radical 3 times -1. And then we're putting it together. 1 times 1 is 1. And that's going to be minus radical 3. That's kind of ugly, but it's fine. I'm doing V to find V. I'm doing the magnitude here. So it's 1 plus 1 squared plus radical 3 squared. 1 squared is 1. Radical 3 squared is 3. So 1 plus 3 would get me 4. But what do I need to do with that thing? Square root. My answer is 2. Then I'm doing W. If I'm doing W, I'm doing 1 squared plus -1 squared. That is 2. But I need to square root that thing. That is that dot, or that is that magnitude. It's radical 2. Okay, so I've got my different values. Those three things then are going to go into my equation. So to find the angle between them, I'm using that equation right there. Cosine of theta equals U times V. So my dot product, 1 minus radical 3 all over 2 radical 2. How do I get rid of the cosine? Inverse cosine. So in my calculator, I'm going second cosine. Alpha F1. I'm using my fraction button. On top, I'm typing in 1 minus radical 3. And on bottom, I'm typing in 2 root 2. I hit enter. Boom. 105 degrees. Okay. 105 degrees. That is my value here. That's what theta is. The reason for that is if my x is 1 and my y is -1, that means I'm down here at like -45 degrees. If my x is 1 and my y is radical 3, that is like I am up here at 60 degrees. So guess what the difference between those two angles is? 105. Yes, ma'am.
I thought the exact thing in my calculator. I got an error. I don't know.
You go to syntax error, click go to, you used a negative sign instead of a minus sign. Good news. Was the front hard? Back's like 3 times easier. So let's go to the backside. We've got this cool thing on the backside. Notice that the answer, I didn't bring this up, but it's always going to get you a value between 0 and pi. Okay, 0 and 180 degrees. Because like if you had an angle like this, instead of measuring this angle, they would just tell you the other side. Okay, so my answer is always going to be between 0 and 180 when I find the angles between two things. Two vectors are said to be parallel if there is a non-zero scalar alpha, so that the vector v is equal to alpha times w. In this case, the angle between v and w is blank. So if you have two vectors that are parallel to each other, what would the difference in the two angles of those vectors be? 0 degrees would be something like if I had a vector like that and then another vector like that, what's the difference in their angle? Nothing. They're the same angle. So it'd be 0 degrees. That's one of them. Or what other could it be? 180, because 180, it's going the same angle. The difference is it's exactly the opposite direction. The arrow's pointing the other way. So if we say two things have a difference angle of 0 and 180, then they're parallel. You could do this by doing the exact same thing we did on the front. Okay, what we did on the front with the little cosine formula, that works here too. If you get 0, 180, it's parallel. Or you could do this scalar multiplier thing, and I'll show you what that means. But just for the sake of seeing it, let's graph these two vectors. So 3i minus j, so 3 comma negative 1. So I'm going to pick a dot. I'm going to go 3, 1, 2, 3, down 1. There's my first vector. And then w, so this was v. W is negative 12i plus 4j. So I'm going to pick a dot. I'm going to go left 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 4. 1, 2, 3, 4. Oh, no, that's not straight at all. Terrible. It's garbage. But there we go. That's v and w. Would you agree that those two things are parallel to each other? Are they ever going to cross if I were to continue to extend them out? No. So they're parallel. Okay, and we could draw them. We could do the formula we did on the front side, or you could do this. Is there anything that I could multiply this smaller vector by? Okay, it's smaller because it's got smaller numbers. Is there anything I could do with that vector that multiply by something to make it equal to negative 12 and 4? Negative 4. If I were to take this vector, 3, negative 1, and I were to simply multiply everything by negative 4 and distribute it out, then my new vector would be negative 12 and a positive 4, which is the same thing. The difference between those two vectors is what? What was the difference here? 180. And you could tell it's 180 really easily, all right, because they have exact opposite signs. If they were the same sign, they would be 0 degrees. But this is 180 degrees. They're parallel. So if you could just take them and multiply by a number, boom, they are parallel to each other. Everybody good there? If the angle between two non-zero vectors is pi over 2, what's another angle for pi over 2? 90 degrees. If the difference between two things is 90 degrees, what's true about those two vectors? Kind of. Perpendicular is a great word. Perpendicular is when you're describing two lines. Two lines are perpendicular. Okay. Later on, we're going to have a curve and a line, and we'll be able to use a second word that means perpendicular, which is a normal line. A normal line is a slope that is perpendicular. But when we have two vectors that are perpendicular, we get a third math word, my favorite of the three, orthogonal. Orthogonal. If you have two angles that are 90 degrees apart, they are orthogonal. Means perpendicular. Two vectors, v and w, are going to be orthogonal if and only if their dot products, v times w, equals 0. So you don't have to do the whole thing here. If their dot product is 0, they're orthogonal. And let's look at why. If this top part is 0, does it matter what this bottom part is? I don't care. It's just some number. If I do inverse cosine of that, when is cosine of something going to be 0? At where? No, not at 0. Quit saying 0. 90 degrees. At 90 degrees, cosine is 0. Oh, yeah. So that means that they are perpendicular or orthogonal. Okay? Find the dot product of these two things. See what you get. Are these two vectors orthogonal? Yeah, they are. Because all you got to do is dot product. You take 4 times negative 3. This guy times that guy. Plus this guy. Negative 6 times negative 2. That gets me negative 12. Plus 12, it gets me 0. If that's 0, they are orthogonal. Questions on something we learned today?